desirable properties that should satisfy preferences of a consumer. In budget line, we were able to basically find out how the two goods X and Y interact with each other, and given the money income that the consumer has, how we are able to draw the budget line in the XY space. Okay, so in the XY space, M by Px and M by Py are basically the two intercepts of X and Y. Okay, and in terms of preferences, we have already defined a few desirable preferences, like number one would be reflexivity, then would be transitivity, monotonicity, strict convexity. Okay, these are a few desirable properties that you as an economist would prefer your preferences to have. Along with this, obviously, the basic property of completeness, that the consumer exactly knows which bundle he or she prefers over the other bundle. So any two bundles that we can talk about can be compared. That is completeness. So any sort of a bundle, say X0, Y0 and X1, Y1, the consumer exactly knows whether he prefers this over this, whether he is indifferent to this, or whether X0, Y0 is inferior to X1, Y1. Okay. Basis all the preferences, basis that these preferences gives us something called a utility function. Okay. We were able to talk about indifference curves, right? And we saw that indifference curves, if they have to satisfy all the properties, they would give us curves like this. Okay. Now, given typical well-behaved indifference curves and given a typical linear budget line, it is important for us to talk about something called optimization. Okay. That is, how does the consumer decide on their optimal bundle? And that happens as follows. I need to basically combine the two diagrams. So given the preferences of the consumer would have a typical budget line. Now the typical budget line would give you the highest indifference curve achievable at a point like this. Now what is happening is that the slope of the indifference curve and the slope of the budget line would be the same. Okay, take a look at this point. This point is where the slope of the budget line is the same as the slope of the indifference curve. See, the indifference curves are like this. Now I know that the utility is increasing. So given this green budget line, the highest indifference curve achievable would be at a point A. And at the point A, it's very easy. We can see that the slope of the budget line is equal to the slope of the indifference curve. And that gives us the result that the slope of the budget line, which is minus Px by Py, is equal to the slope of the indifference curve, which is minus marginal utility of X by marginal utility of Y. So basically, for standard convex indifference curves and a linear budget line, the optimal bundle is achievable when I compare the two slopes. As simple as that. So for different examples, we would get different results. For different utility functions, we would get different results. So it's important for you to understand that if I have a Cobb-Douglas utility function, I would get a different MUX and MUY. So different utility functions would give me different MUX by MUY, and a few of them cannot be compared. Few of them cannot be compared, right? So it's important for you to be able to understand all of this information and be able to find out the optimal bundle. Okay, so the optimal bundle is found in this particular fashion, that the slope of the budget line is equal to the slope of the indifference curve. That is what we do, and this is how we find out our optimal bundle. Now for different utility functions, I have already given multiple videos for different utility function on how to find out the optimal bundle. You have Cobb-Douglas video, you have perfect substitute video, you have perfect complement video. So different videos are already listed on the student portal in order to see the optimal bundle for the different utility functions. But this is in short the way to find out the optimal bundle. Okay.